Welcome to Physics Online. We are talking about gravity. We're in Module 1 of Quarter 2. Okay. Let's talk about the Newton's law of universal gravitation. I'll get it. English and I. All right. So Newton did realize that the force that pulls anything to the ground, an apple, let's say, is also the same force that keeps the moon in orbit. Okay. Let's go ahead. There is a formula. The formula F sub g, force of gravity, is equal to the gravitational constant times the one mass, the first mass. There's two masses here, right? In order for two things to be attracted, I got to have two things. If I only have one thing hanging out in space, it'll never be attracted to anything else because there's nothing else for it to be attracted to. So mass 1 times mass 2 divided by the radius squared. Okay. I'm going to go ahead and pause the video for a minute. My grandkids just came in. All right, I'm back. So let's look at some of the math here. First off, one more thing you need to know. What is G? G is a gravitational constant. It's a multiplier that tells us how strong the force is, right? So if I there we go. G is equal to 6.67 times 10 to the negative 11, and it's newtons times meters squared over kilograms squared. That's its units, okay? Notice this negative 11 right here. What that means is I can write this another way, right? I'm going to write this as a decimal. So I'm going to start over here. I'm going to say point, and I got to put, I got to move that 11 decimals to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7 newtons times meters squared over kilograms squared. Okay, look how small that number is. So I could have a really big number here, and because I multiply it by this really small number, it doesn't mean much, right? So let's do that. Let's say that I've got a force, a Newton force. Let's say I've got this force here, because that's what we're calculating here, right? This force. And let's say I take this, right? And notice, this is going to be kilograms here, and this is going to be meters squared here, right? And because I'm taking kilograms, so let's go ahead and let's say 100,000 kilograms times 100,000 kilograms, and let's say that is 1 meter squared. The radius is 1 meter, so 1 meter squared. Sorry, that shouldn't be there. That should be there. Meter squared. Okay. So 10,000 times 10,000. Let's pull our calculator up. $10,000. So this is, this is two really big objects. 10,000 times 10,000 equals 100,000, and I did 1 meter squared, right? Which, that means I'm going to divide that by 1,000. By 1, sorry, which is the same thing, right? But now what I'm going to do is I'm going to multiply that by this number right here, which is, I'm going to go times point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 6, 7 equals, and look, it is a very, very small number, okay? So gravity is a very small force. It's not very large at all. But the other thing you should notice is that as I increase my, this is because this right here, because this right here is multiplied, right? As I increase my weight or my masses, I increase the force, right? All right, we're going to go ahead and jump into our next video after this. I will see you in that video. Again, I'm so glad you're here. Let's go play.